We've just gone through and normalized our database design by running through the requirements of the normal forms. Here and there, though, there might be a reason to undo some of those changes, or keep our database design in a format that doesn't strictly adhere to the requirements of a particular normal form. This is a process called denormalization. Denormalization should be approached with caution, and you need to be very specific as to your reasoning for not having your tables meet third normal form. The normalization process is all about removing redundant information from your database and helping to prevent data anomalies that can creep in when repeated information isn't updated simultaneously. So why would you want to denormalize a table? Well, there are two reasons: performance and to track historical data. First, let's take a look at performance. You might have noticed that the common solution to all of our normalization procedures was to create additional related tables and move the offending columns into them. And while it makes for very efficient data storage, it increases the time it takes to access the related values when a DBMS needs to go looking in multiple tables and join them back together in order to return the requested information. Here's an example. Earlier in this chapter, we normalized the Explore California Tour table to move the text description of the tour difficulty to a new table, but left the numerical value in place. When we need the number, it's right there with the rest of the tour information. But when we need the text description, the database has to find the number, then look up the description in a different table. In our business use case, if we're using the description just as often as we need to reference the numerical designation, then it might make sense to keep both of them in the same table, even though this is a violation of third normal form. By doing so, the database doesn't need to fetch two tables every time this information is requested. The other reason to denormalize a table is in order to store historical data. In a properly normalized database, all of the tables display the current state of the information. If we look at an invoices table, it is linked to a specific customer, and the customer table stores their current address. If we were to look for historical transactions from the same customer, you would end up following a path that always returns you to their current address, regardless if they've recently moved or not. Instead, what we can do is create address fields in both the customers table and the invoices table. When a customer conducts a new transaction, we'll have the DBMS copy the address from the customer table and store it in the invoices table. Now, even though this technically doesn't follow the normalization rules, it also doesn't introduce data anomalies, since one address represents the current address and the other represents the address at the time the purchase was made. It's important to stress that once a table has been denormalized, it loses some of the protection that was being provided against data inconsistencies. It's up to the database designer to ensure that these duplicated values remain synchronized by implementing programmatic rules or constraints in the user interface, or by using other techniques whenever changes to the data occur.